Welcome back, ladies and gentlemen. We're going to look at example 3. And you see on the chalkboard, it might be small for you at home, so I'm just going to read it out to you. Just to recap again, for this question that we're supposed to do, it says convert y equals 2x squared plus 5x minus 1 equals into vertex form by completing the square. So another completing the square. And again, maybe I didn't make it clear. Technically, the way that I like teaching it, there's a fast way and then there's a proper way. This is the proper way. We can definitely use the fast way if you want. And so in this example, what you're supposed to do is partial factor the a term across the first two terms of the quadratic. That's in standard form. Then you take that new b value, and I like doing it off to the side, and you divide it by 2. And then the third step is, of course, you square that division by 2, and that's going to help you by your adding and subtracting for 0. You'll see in a moment when we get there. And then you complete the square by actually factoring the perfect square. That's the whole point. This stage number 5, completing the square, that's actually why it's called completing the square. And then a lot of students screw this up, that's why it needs to be said. When you complete that square though, there is still this remaining negative term that needs to be dealt with, which is affected by the a term that you distribute. And finally you collect the like term. So hopefully you'll see it as we do the example here. So watch what I'm going to do. And again, slow me down class if I'm going too fast. One more time, this is a standard form of a quadratic. The a term is 2, the b term is 5, and the c term is -1. And so it says completing the square. So one more time, the first step is partial factor a across the first two terms. Notice it's not a true factoring. Everyone agree? And I'm going to use fractions because technically, if there's no decimals in the question, I should always be using exact form. Fraction forms or radicals or anything like that. And again, you can always check your answer by actually expanding this, right? So you should get the above line, right? Now watch what I'm going to do. I actually don't do this, and again, it shows it nicely on the PowerPoint. I take that new b. What's the new b? I'll underline it in yellow so you guys can see it. And we're going to divide this by 2. Is this what step 2 says? Take that new b. That's the power of 2. That's what I call it, not b, but new b. And divide by 2. And what does that equal? I think everyone agrees that's 5/4. Right? So if you've forgotten, division means multiply by the reciprocal. Third step, what are we going to get? Square your answer from 2. So we're going to square this. So I like just rewriting it again. And notice I'm just doing it off to the side. You get 25/16. In fact, it's always going to be positive. This is usually done well, and in fact, it's a kind of a neat way to figure out perfect square numbers, especially when we do not have nice values. In this case, the not nice number is that 5/2. So we're now at step 4, and we're going to add by 0, not just any 0. This idea of adding by 0, right? Like Maria plus 0, still Maria. Maria subtracts 0, still Maria. Nothing happens with zeros. So a lot of you knowing what I'm doing here. And I'm going to use my answer from 3. What was my answer in 3? This was the answer in 3, and I'll annotate so you guys can see it. We're going to add 25/16, but you can't just do that mathematically. That would be magic. We can only do things that are mathematical. So this idea is adding by 0. Good question if some of you thought about it. Does it matter the order? Technically it shouldn't. But a lot of you know that perfect squares, the c term is always positive. So perfect square. The c term must be positive, and that's what we're trying to do. The x squared plus 5/2x plus 25/16, that's a perfect square, even though it's not comfortable. You're not used to seeing it that way. So just to show you what I'm talking about, this is the step called step 5. Complete that square. And that's why this example is a little bit better than the one that we did. Notice I use square brackets so you can see what we're doing. I'm factoring this to make this perfect square that's been factored. This is hard to do for some of you. In fact, I would agree. But you know, we can cheat a little bit. Why? Because when you complete the square, we can actually use our answer from step 2. And I forgot to put that step from step 2. And what was that? Plus 5/4. One more time, if you don't believe me, take the x plus 5/4 squared and expand. And if you were to expand that, you would get the above trinomial. But the why it's called completing the square is because in vertex form you want to find that vertex, right? Notice now we're at step 6. Distribute the 2 and clear those square brackets. So 2 and this first bracket. Notice you get 2 in that bracket. That's fine. So notice what I'm doing. I just arrow that. And then 2 times that. That's negative 50 over 16 minus 1. And I think I made a boo. Oh, I can reduce this. Everyone agree I can reduce this fraction? Mm-hmm. Can anyone help me out? Yeah, so don't get me wrong, I would do this first, or like the 2 divides up to 16, right? Everyone agrees? But I'm going to change that right now, even though this is fine. And then you would reduce it, but it's better to reduce now, 50 over 16. So 25 over 8. Is that okay, ladies and gentlemen? Did I confuse you? Anyone? It's just because this is even. And then it's easier now to collect like terms. Notice negative 1 is the same thing as negative 8 over 8. So our final answer is going to be y equals 2 times bracket x plus 5 over 4 squared minus 33 over 8, I think. Mm-hmm. And so one more time, let's annotate this so people can see. This is the first step. Partial factor the a across the first 3 terms. This is step 2. Take that new b, divide that by 2. This is step 3, squaring. Don't get me wrong. You can all obviously consolidate. Step 4 is right here, the adding by 0. Step 5, completing the square, is this direction here. Step 6 is actually this distribution, so that's why we get this answer here. And step 7 is right there by collecting the like terms. Many students actually, once in a while, once they go through this slowly, they realize I can actually skip this step. And most students will just go to this one, so they do this, then this line, the second line, and then go to the 4th line, and then 5th and 6th. So they just tend to skip this, but this is actually the essence of why you're doing it. If you're going to teach somebody, if you want to help them out, that's what you do. And again, this is the example for question 3, A, completing the square. Let's determine the roots. Notice, unlike our example 2 had nice values using radicals. So this is the third way to find those roots for question B. Determine roots by the quadratic formula. So a lot of you know that the A term is 2, the B is 5, the C term is negative 1. Quadratic formula is as follows. So this now just make sure you know how to input and do algebra. So negative 5 plus or minus 5 squared minus 4 times 2 times negative 1, all divided by 2 times 2. Before we continue, everyone okay with my substitution? And I think we get this answer, negative 5 plus or minus the square root of 33 over 4. Notice if we ask you for the exact answer, this is the exact answer. And again, just like your classmate asked, what are the 2 real roots? The first root is negative 5 plus the square root of 33 all divided by 4. And the other one is negative 5 minus root 33 all divided by 4. These are called the 2 real roots. Approximately, any volunteer? I'm going to get the approximate answer. And this over here is the approximate roots. Anyone want to help me out with the calculator? You just square root 33, you add it to negative 5. The answer, make sure you press equals. Because you have to do the numerator first. And you have 4. And then vice versa. You want to actually get the roots? You can give it to 1 decimal place if you want. Any pressure? Grace?
0.2.
That's correct. And the other one? Did I actually get the other one? Right?
Negative 2.7.
Is it negative 2.7? Yeah, it's negative. I got something wrong. I'm stupid. Someone look like that? I think it's negative, right?
Yeah.
That's negative minus negative divided by positive. Negative. That's what. So those are the two approximations, right? Let's see if that got on the screen. It did. Determine the rules of transformation to describe the transformations. So, and notice that's why vertex form is kind of neat. Oops. So any volunteer actually want to help explain this? Maybe try to do this, and don't worry, I'll give you the answer to the table. And we're almost done. Does anyone remember from grade 10? What is the, when A is 2? Flora, do you remember?
Oh wait, A is 2 is like, it's like you're you're stretching, is that the word for it? Like, to like, I'm not sure, like, to move, like, it just goes like.
It goes like this? Yeah. Ladies and gentlemen, you
like,
see it, she was off screen, but she did this. That's correct!
It's like
So,
compression and stretching.
Yeah, but there's a significance, right? So when A is equal to 2, don't worry, it's all good. I'll talk about it. So this is, when you write this out, this is a vertical stretch by a factor of 2. Nice. I think everyone agrees with the P value in this case. Any volunteer want to know what the P is? Okay. And if you need some help, look in the box part. What's P and what's Q?
Negative 5/4.
Thanks, Bridget. So negative 5 over 4, and the Q I think is negative 3 over 8, right? So let's just talk about this. This means horizontal shift, not just forwards, direction left, 5 over 4, or you can negative 5 over 4 if you want. And then vertical shift down. Negative 8. Here's that diagram diagram. I apologize. I'm not going to do the x, y, that's okay, because it's the same. Well, maybe. Okay, that's from the parent. So let's just move this over so people can see it. Sorry. So what do we got? So what we're going to do is x minus 5 over 4. And then 2 times y minus 33/8. So if you're still not too sure what we're going to do, I do recommend, even though we divide it this way, although you can do them left to right, most people read from left to right. Most students that I teach, we take all the x values and you just rinse and repeat this by using the calculation. So I'm just going to give you the decimal answer if that's okay, just to speed it up for the lesson. But I encourage you, ladies and gentlemen, please look at the PowerPoints or try it yourself. What I'm doing is negative 2 when it's x, and I'm subtracting 5/4, right? So what we're getting is negative 3.25, and these are the answers. Negative 2.25, negative 1.25, negative 0.25, oops. And the last one is 0.75, I believe. And then, you're going to take that 4 times by 2, subtract 33/8. So some of you know there's a fraction button on your calculator. You're going to get 3.875, negative 2.125, negative 4.125, negative 2.125, and of course 3.75. And again, this mapping technique, we tend not to teach it that way because a lot of you, this is very hard to graph. To sketch this out, most students would have done it this way. So that's negative 1 there. Negative 1.25 is maybe right about here. And negative, like I can't, it's like way over there, but I think it's negative 4.25, so negative 4 from here. So something like this. This point's there. And just like your classmate, I think it was Florence, she did woo, like this. So it's reversely stretched. It doesn't sketch. So you might not have enough room. Let's just pause there. Any questions from the class?